So welcome to the session on the hypothesis of punctuated equilibria. According to Darwin's natural selection theory, evolutionary changes are the results of gradual accumulation of small inheritable variations. So Darwin stressed on gradual uh, process or gradual change for the evolutionary process. But this particular concept was questioned through the studies conducted by Stephen Jay Gould and Niles Eldredge in 1972. Stephen Jay Gould was America's foremost writer and thinker on evolution, and Niles, he was from Harvard University, and Niles Eldredge is a well-known paleontologist at the American Museum of Natural History. And on the basis of paleontological studies, particularly on trilobites and snails, Gould and Eldredge, they suggested that most of the species in the world appear to have evolved relatively quickly and then persisted for millions of years virtually unchanged. That is, they remained in a state of stasis or in equilibria. That is how the term comes, equilibria. Okay, right. Conspicuous, I hope that is clear. We can just explain with an example. Okay, this is just a representation to show the punctuated equilibria. Okay, so here what does it say? That the what you call a species evolved relatively quickly. So this is one species, another species from the species A here. Okay, this is an system. So this species it arose quickly or evolved quickly, and then it remained for a long period of time without much change. That is, it persisted. Okay, with the same character, it remained on the earth for quite a long period of time. Okay, and this particular there was an equilibrium, right? And conspicuous evolutionary changes are concentrated in those brief periods known as punctuations, when the lineage actually split or burst into new species or branch into new species. So whenever a species divided into two, at those particular points only evolutionary changes, conspicuous evolutionary changes were concentrated. Okay, and those periods were known as punctuations, right? So these are equilibrium, and whenever a particular species divided into two, there it was punctuations, and at that point we can see conspicuous evolutionary changes. Okay, so this was what Gould and Eldredge brought forward. So most of the species evolved relatively quickly and then persisted for millions of years with virtually unchanged. Okay, that this is what is referred as in equilibrium. Okay, and conspicuous evolutionary changes are concentrated in these brief periods when the lineage split, burst or branched into new species, and those time when there had been conspicuous evolutionary changes is what is referred as punctuations, and this put together came up with the hypothesis of punctuated equilibria. Okay, Gould and Eldredge, they advocated that the origin of new species through rapid evolution occurred when a small local population became isolated at the margin of geographic range of parent species. And indeed, the successful branching of a small isolated population from the periphery of the parental range virtually assured the rapid origin of new species. So in geological time, the branching is sudden, maybe like thousands of years or less, compared to millions of years of lifespan of the species. So once established as a new species, it is believed that little evolutionary change will occur in that species over geological time. This stasis or equilibrium is then interrupted or punctuated by short bursts of rapid changes. So in other words, evolutionary processes occurred by short episodes of rapid species formation during long periods of genetic stability. Okay, so when you look at this particular figure, this is actually the long period of genetic stability, and it is over here when there is a branching, that is there is a what you call short episodes where rapid species formation occur. I hope it is clear. Okay, so at those what you call points where, or those short episodes of rapid species formation is what is referred as like the punctuations, and the longer periods of genetic stability is what is referred as the equilibrium. Okay. Now the hypothesis of punctuated equilibrium does not fully discard the gradualism or the gradualistic view of the speciation or origin of species as put forward by Darwin. Okay. When Gould says that species arise relatively quickly, he means in relation to the rate at which fossils accumulate, in which 50,000 years is little more than an instant. Okay. And the theory of here you can see there are two major concepts, one is gradualism and punctuated equilibrium. Gradualism was put forward by Darwin, and punctuated equilibrium was what was advocated by Gould and Eldridge. Okay. Gradualism is when you can see, according to gradualism, types B and C gradually evolve from type A. Numerous transitional fossils are likely to be found in this lengthy period of geologic time. Okay. Here you can see in this figure, this is gradualism model. Okay. So, these two species have originated from this particular ancestor, and during the course of evolution it has passed through many intermediate stages or intermediate forms, and all these forms may be found as transitional fossils. When you start to trace back the evolutionary history of these two species, we may come across many transitional fossils. Okay. So, this is what gradualism is all about, and according to punctuated equilibria, species the types B and C evolved so suddenly from type A that transitional fossils are difficult to find in this brief period of the geologic time. Once formed, the species remained essentially static during its long lineage, and then one should not expect a continuous series of transitional fossils in this case. So, hence it is argued that lack of abundant intermediate forms or missing links is a genuine result of evolutionary process itself rather than the failure of preservation of fossils. Okay. So, here punctuated equilibrium, here it says that it is so sudden. Okay. The speciation is so sudden that intermediate fossils cannot be obtained. It is not because there are no no fossils preserved, but it is because there are no transitional stages at all. Okay. That is what Gould and Eldridge supports. Okay. So, this is about the punctuated equilibrium, and there are few examples examples of rapid evolution in animal species, where it was Hampton Carson of the University of Hawaii in Honolulu who demonstrated in the studies conducted in 1970s. He observed that animal speciation can occur rapidly within relatively few generations, and this has been supported by evidences in populations of picture winged flies of the family Drosophilidae. Drosophilidae family includes Drosophila, I hope you know that fruit flies. Okay. Among them there is a fly, the picture winged flies, which are found in the high altitude forests of the Hawaiian Islands. Okay. And there are about 26 species of picture winged flies on these areas, but the most isolated ocean islands in the world. Okay, these are the most isolated ones, and on the basis of analysis of chromosomal inversions, Hampton Carson infers that migrant population of these flies gave rise to new species rather than simply to new colonies of parent flies, and such a process of almost instantaneous speciation seems to have occurred repeatedly in the population of Hawaiian flies. Two reasons are there. One is it is completely isolated, and the population which had reached over there had to face or experience its own kind of natural selection processes. Secondly, the 26 species of the flies originated from the same stock. Okay. So, that was an instantaneous speciation, and it is still have occurred repeatedly in the same population of the Hawaiian flies. Okay. So, this is about the hypothesis of punctuated equilibria. Fine. Yeah. Thank you.